So the mole map that you had previously in an earlier unit had numbers of molecules, atoms, and formula units, mass of a substance, and volume of a gas. It didn't have these two things on this side. Notice that whatever you're starting with, you always go through moles. Okay, that's what's here in the middle. We're always going through moles. So you can start with any one of these kind of things up here, and you can go, as long as you go through moles to find the second substance, and that's what stoichiometry is. Stoichiometry requires this step right here. It goes from moles of one thing to moles of another. That's what stoichiometry is. Any kind of calculation, we have to go from one substance to another, requires stoichiometry. And so you can go from any one of these kind of measurements through moles. You convert things to moles first, then using molar ratios, and that means you have to have a balanced equation. You can calculate into a product or some other thing you're looking for in any form you want to. Okay, Shane, please don't make me ask you to be quiet and turn around again. Huh? Okay, sorry, Reese. Okay, I understand, but let's just pay attention, all right? Let's turn around, okay? Thank you. All right. All right. Let's just don't argue, okay? It's taken care of. It's taken care of. Yeah, kind of getting close, isn't it? All right. All right. Now, the new thing then in this unit is all about solutions. So we have molar concentration and volume in liters. Those are the new things that you still can go through this mole ratio to find molar concentration or whatever the other thing you want to do. And we're only going to try to do one kind of stoichiometry. All right. Does everybody have low blood sugar today, or what?
I don't know what's wrong with
I know. All right. Yeah, that is chemistry.
everything is chemistry.
That's right. There's a term that's often used for chemistry where chemistry is considered to be the central science, and there's a reason for it.
I think biology. I don't remember anything about it.
Look, listen, I'm only going to say one thing about that. The further you go in biology, the more you have to know about chemistry. Okay? All right. Quiet, please. Shh. All right. So let's look at a problem. We're going to have to go from some measurement of something through that molar ratio to some measurement of something else. Okay? And so this is a really common thing that's done in chemistry labs. It's done in food labs. It's done in the food industry. It's done in the soft drink industry. It's done in the cleaning industry. Huh? Juice industry, sure, absolutely. Okay? The way that you tell whether something how much vitamin C something has is using something called titration, which requires the kind of calculation we're talking about here. Okay? So let's start with something a little bit simpler than titration for finding the concentration of vitamin C, and let's do something here that's a little bit simpler than this. Okay? Please write this down with me. I didn't plan on it. Okay. The problem with going over homework where most everybody at least got the basic process right is people tune me out. And we have the class descended into pandemonium. Okay? So I just scanned through it visually and saw that most people got most of it right. Okay? And even though there was what I went over were the little things people were getting wrong. Okay? Oh, significant digits. That's something else people are getting wrong. And that goes back to the very first unit in here. We learned about significant digits in here.
Okay, what are we doing now?
This is something new, okay?
Stop flirting with me.
I ain't flirting with nobody. He just looked at me, he said hi. I thought he was going to be rude and not speak.
Jasmine?
He's sweet. I think I made new friends. He said, hey, I thought he was about to be rude, but I didn't have to be mean to him. Oh my gosh. Will.
I think we'll
get
jealous.
Will is.
But I thought that was
Please write with me. Please write while I'm writing.
But I'm trying to ask you. Like, do I go now?
I'm going to leave that up to you. Here's the thing. There's no good time to leave this class. Okay?
That's why I stay out the whole class here.
Are you ignoring me?
Yes, at the moment I am.
Oh.
Well, that is so rude. Where are you at? Okay. You ain't a little mental. I got problems with people who don't know.
We have a selfish.
Shane, I'm gonna put you in the box.
Wow. I'll break out of it. I can break your box.
You're a Christian one.
I go to equal box.
I can't hear you.
Look, I'm getting a little bit frustrated with the people who aren't writing, paying attention, focusing, okay? And if I get a little too frustrated because I don't think I can control the class adequately, so if everybody can learn, I'll start sending people to ISS, okay? So please don't push it to that point, okay? All right. What word in this sentence, or this question, there is one sentence in it, okay? What word in this sentence indicates there's a chemical reaction here? Is it neutralized? There you go. Good analysis. Okay?
It's right there.
It is there, yeah. That's a chemical reaction word. That means there's some kind of chemical reaction going on. All right? What we have to do is to figure out what our starting stuff is and what our ending stuff is. Okay? Now the starting stuff in this case are the two chemicals listed. It doesn't tell you what the ending stuff is. We're going to have to figure that out. Yes?
25.5.
It's 25.0 milliliters. Okay? All right? So we have two different chemicals listed here and said that one is neutralizing another. Well, you should know that acids neutralize bases, right?
Yes.
And bases neutralize acids, don't they? And this is an acid here, it says so. Well, sodium hydroxide happens to be a base, or it wouldn't be neutralizing the acid. Okay? And almost anything that has hydroxide on the end is going to neutralize an acid. In the next unit, when we get to acids and bases, acid and base theory, we'll further define that, okay? All right, so we're neutralizing an acid. That means that this stuff here, sodium hydroxide, has to be a base, because you have to have a base to neutralize an acid. Does everybody understand that from physical science? Remember that? All right, so we need to write the formulas for these two things. All right, how do we write the formula for sodium hydroxide?
Is it
Na is the
NaHO group? I don't know.
Na is sodium. All right.
Oxide.
OH is hydroxide. And if you didn't know that, you'd have to search around your periodic table, look for sodium hydroxide. If you don't see hydroxide, then it's probably on the polyatomic ion list. So sodium is on the periodic table, and hydroxide is on the common ions list. And sodium, if you look on the periodic table with oxidation numbers, has a 1+ charge. And hydroxide, if you look on the common ions list, has a 1- charge. So I hope you can figure out that this one, you don't have to do a whole lot of math. This is going to be ENaOH. Okay? All right, hydrochloric acid. We learned to name acids, and we also should have learned how to take the name of the acid and figure out a formula. If I have the prefix hydro on the front and the suffix ic on the back, if I have the prefix hydro on the front and ic on the back, that means it's a binary acid, just 2 elements. Not necessarily 2 atoms, but 2 elements. Okay? I want to look at this. Here's the root word. What element do I get from this root? That's chloride. Okay? Chloride. Okay? Well, the symbol for chloride is Cl. And to make an acid, I'm going to put hydrogens on the front. And those hydrogens have a 1+ charge. So now I go to the periodic table with oxidation numbers and find the charge on the chloride. What now? This concentration is not in the packet. Hmm?
He said at the beginning of the packet that everything's not going to be in there.
Okay. There are a lot of things in there, but some things aren't. You know? All right, so what charge do I put on this chlorine? Huh? 1-. Okay. Well, I hope you can see I gave you a pretty simple one here. This is simply HCl. Is there anybody that doesn't understand how I got those? Okay. So those are our 2 starting amounts. All I did was put together the formulas here. This is all reviewed. Now we'll put those 2 formulas into an equation, a chemical equation, to show the neutralization. So I have HCl, and I have NaOH. It says the sodium hydroxide is a molar solution. It says it's molar. Well, molar applies to solutions. Let me back that up because I said it was a molar solution. It says it's molar. Molar is only used for solutions. So it must be dissolved in water. So I don't have to even look that up on the solubility rules or anything. I know that this is dissolved. Okay? Because it says molar. All right? And it says we want to find the concentration of the acid. Well, concentration is all about solutions, isn't it? Okay? So this must be aqueous too. Now, it could be dissolved in something else, but remember, unless I tell you what it's dissolved in, you always assume it's dissolved in water. Okay. So now we've got the front half of a chemical equation. So looking at these formulas, what classification of reaction do you expect we'll have? Double replacement. Well, all neutralization reactions that we've done in this class are double replacement. Okay, so that could have been a clue right there. All right, but yes, this is double replacement. We have an acid, and we have what we call at this point anyway an ionic compound. Okay, and this is in 2 parts, and this is in 2 parts. In fact, the name kind of tells you that anyway. So what the front part of this has got to go with the back part of that. The front part of this has got to go with the back part of that. So let's put H with OH. We're going to put the H part with the OH part. Yeah, I'm going to write it HOH just to emphasize that point. Okay, which is perfectly okay. You can write it H2O if you choose. I like to write it that way because it shows what's happening more. And what physical state do we assign to H2O? What physical state? Liquid. Unless there's heat to turn it into a gas, we're going to call it a liquid. Okay? And so what's left then? We're going to put the front part of this with the back part of that. What do we get? Okay, this was a pretty easy set. Okay? All right. Now we've got a chemical equation. We kind of have what we need to go about starting out the stoichiometry. Now we got to figure out this a little bit. This is the only really new thing here, is how we set up stoichiometry with solutions. Okay? So listen carefully. Here's the rule for you. The rule is your starting amount will always be the amount of the chemical whose concentration you know. The starting amount will always be the amount of the chemical whose concentration you know. Okay? Your starting amount when you're doing solution stoichiometry like this will always be the amount of the chemical whose concentration you know. All right. So read the problem. Let's decipher the problem here. Okay? Which one of these chemicals do you know both the starting amount and the concentration? Sodium hydroxide, NaOH. We know we know the amount and we know its concentration. Okay? So we're going to start with that amount because we know its concentration. And that's sodium hydroxide. That's the species here, NaOH. Okay? All right. Since we know this amount, and we know that if we're going from one species to the other, and that's what it says, we're going to start with this amount of this stuff. We want to know the concentration of the other stuff. We're starting with the given amount sodium hydroxide, and we want to find the concentration of another species. That means we have to do stoichiometry. That means we have to balance the equation. That means we have to have a molar ratio, and that means we got to get the starting amount in moles. Okay? We got to find our starting amount in moles. All right, this is where you got to know. This is where you got to know that molarity, molar concentration, is in moles of solute over liters of solution. You've got to know that. Okay? We learned to calculate molarity previously. Now we're going to use it. So now that you know this, this allows you to get to where we want to go. See, we got moles on the top. That's where we want to get to, isn't it? What if I put that here in this form? So instead of having 0.20 capital M, I want to write it 0.20 moles of that stuff over liters of solution. How about that? Watch me. 0.20 moles, because I can, if this, molar means this. It means both of these, doesn't it? Moles of this sodium hydroxide over 1 liter of this sodium hydroxide solution. Okay? That makes sense? Huh? Well, we're not quite ready to do that, because I can't cancel milliliters with liters, can I? I need to convert milliliters into liters first.
Oh, hold on. How you mean you got only 1 liter? Why you put 1 liter?
Okay, because it's over liters of solution.
So it's going to always be 1 liter.
You can say it's, I mean, put it over 1 doesn't change it, does it? Okay.
Milliliters to liters, you multiply, right?
Well, here's what I want you to do in this class. This is what I've been teaching you since Unit 1. In this class, for a conversion unit, you have to have an equality statement. So I want you to know that there are 1,000 milliliters in 1 liter. So let's see if we can arrange a conversion unit based on this equality statement. 1 liter over 1,000 milliliters. Okay? Well, now everything will cancel and leave us with moles. Milliliters can go away. Okay, liters can go away. We're left with moles. Now, there's one thing I can actually, here's what I need to point out to you here. The milliliters here is a sodium hydroxide solution. Okay? So this basically this cancels out too. And we're left with, when we get done, we'll have moles of NaOH. Okay? Alright, that's where you get out your calculator. So 32.7 times 0.20. And we're going to hit enter. And then we're going to divide by 1,000. And when I hit the divide key, it automatically plugs the answer in for me. And we're going to divide by 1,000. Okay? And we get this answer here. Well, I don't have to do any rounding off because, well, actually I do. I need 2 digits, don't I? Okay. Here we go. Round that off. So we get 0.0065 moles NaOH. Okay? Alright, let's look at that mole map. Here we go. We started with molar concentration. There it is. Nope, we started with volume in liters, I'm sorry. Well, we converted to liters. Then we used the molar concentration to get to liters. I mean to moles. And that's where we are right now. We started in volume and got to moles. Okay? Now we're ready to go from moles of one thing to moles of the other using the molar ratio. Huh? This times this divided by that. You didn't get that?
No, I got 1 0 in front of me.
Alright, let's try it again. 32.7 times 0.20. Hit enter. You should have 6.54. Is that what you have? Alright, now you're going to divide by 1,000. Is that what you got? Hit enter now. You got it now? Okay, that's fine. Hey, look, you've seen me do that, make that same mistake, haven't you? Okay, so don't feel bad. Yeah, okay. All right, now, so now this becomes our new starting amount, 0.0065 moles of NaOH. Now, somebody's watching here who isn't in this class, and they're further along in chemistry, maybe in college or an AP class or an honors class even, and they're looking and saying, wait a minute, he's propagating an error. Well, you're right. I just want my students to practice the rounding off process because it's even at this point in our class, it's still a problem. We have people who have problems with rounding off properly, so I'm emphasizing it by doing that. Okay, so back to the instruction here. So now I need a molar ratio to go from moles of one thing to moles of another. That's where we are on the molar map right here. Moles of one thing to moles of another. Okay? And let's see. So we're starting with mole NaOH, so there it is, and I've got a coefficient of 1 in front of that in the balanced equation. Okay? So I'll put 1 mole of NaOH on the bottom, and I'm trying to get to the concentration of the acid, so that's this stuff right here. So I'll put that on the top. I've got 1 of those, 1 mole. Yeah, it's going to come out to be the numerically the same, but I have to set this up in order to cancel moles and NaOH. Okay? And that'll allow me to get an answer which is the same numerically, 0.0065 moles, but this time it's not NaOH, it's HCl. Okay? That becomes our new starting amount. Yeah, it sounds just like the stuff we've done before, isn't it? I'm sorry, but this is the deal. Okay, now. Alright, that's our new starting amount. Now here's where it's a little bit different. So this part is stuff we've done before. We've done molar ratios for a month now, easily, if not more, like 6 weeks. Okay? Here's where it's a little bit different. Remember, to get molarity, and what we want is the concentration. This is a concentration unit. Okay, that's what we want. It's some kind of concentration. And this is the easiest one to get to. All right? To get the molarity, we've already got the moles of HCl. We've got to find the liters of solution and put it on the bottom. Well, I don't have liters of solution, but I do have milliliters of solution. Let's do that. Let's put it 1 over 25, 1 over 25.0 milliliters of this HCl solution. Okay? That's going to allow me to have moles over milliliters. But I need moles over liters, don't I? Well, we already know how to convert from liters to milliliters, don't we? Here's the equality statement. There's the conversion unit for that, but we just have to reverse it here. Using this same thing here, I want to put milliliters on the top in order to cancel the milliliters here. 1,000 milliliters, 1 liter. Now let's cancel and see if we got everything set up the way we want it. Milliliters are going to go away. And that's all we're going to be able to cancel. Well, we've got moles of HCl and liters of HCl solution, and that's what we need for a concentration unit called molarity. Okay? So we're ready to do the math now to find our final answer. We got our calculator. Let's see. Set it up. So we got 0.0065 times 1,000. Hit enter. Now I'm going to hit the divide button. It's going to automatically put in the original other answer for me. I'm going to divide by that 25.0 and hit enter. 0.26. So we get 0.26 moles of HCl over liters of HCl solution. Okay, I need 2 digits. That's what I've got here. Okay. But the thing to remember is that you know, actually if you left it in that form, I would have to accept it. That's perfect. That is a concentration unit. It's just simply write 0.26 molar HCl solution.
You can do